All right, so the electricians are here. I think they still need a little bit of time to set up, so I got a little bit of time before power is cut off. My laptop will still work, once power is cut off, but I have to run an extension cord to the router to continue to use Wi-Fi. And then, but I will still have access to my cell phone, so I always have access to Discord, but I may not have the ability to upload videos, not in a fast way anyway. All right, so continuing on with the topic that we have just been talking about, and I'm still looking for. All right, so there we go. So at the end of section 4, it basically talked about it talks about something that we have already talked about. Basically how we can um, uh, we can use reduction instead of translating some of the operators into a bigger and more complex branching structure. So that's basically what section 4.4 is about. And then section 5 talks about comparison, and to be more specific, how do we use a conditional branch instruction? So basically, it boils down to this. If your conditional branch instruction or in C code looks like this, if x, r, y, and r itself being a relation between x and y, go to L1, then it becomes compare xy. Now that's assuming you have the value of x stored in a particular register called x, and then you have the value of y stored in another register, which is represented by the placeholder y. So x, y can only be registers, so you have to compute everything, put those values into registers first. So you have compare x, y, and then whatever the r is whatever this r is. So if this is less than, then r is supposed to be either C for unsigned or L for signed comparison. If r is equal to, equal, then r is supposed to be Z. And that's it, okay? The the toy processor only has those three relations, implemented as a J, something I instruction. So what about not equal to? Well, if you're dealing with not equal to or not less than, then you have no choice but to use section 4.1 to introduce one additional branch and one additional label to handle the negation of the comparison. So there are no quick and easy way for those. Now, what if your relation is greater than? Well, greater than is easy, right? Because if you're dealing with greater than, you just reverse x and y in the comparison, and then you just have a less than here. Once again, your less than is either C for unsigned or L for signed. Okay, so that's basically where you that's the last step, okay, to right before you turn your code into assembly code. So this means everything that you're doing all the way down to section 5.1 is still testable as a C program. So my recommendation when we get to homework assignments that have to deal with this, my recommendation is to do all the flattening and do all the translations and do all the reduction of the expressions in C. Okay? Don't do anything in assembly until you have done everything that you possibly can in C first. Because when you're still programming in C, you still have full access to all the tools that you can use when you're debugging a C program. So you can still use a debugger, okay? You can still use GDB or whatever debugger you have on your platform. You can still use an IDE, you can still use all the fancy tools, you can still use the website that we have found earlier, which is onlinegdb.com. So all those tools are still available, and when you are just working with changing the structure of the program, when you're flattening the code and figuring out that you got all the label names defined correctly and stuff like that. So work on your program for as long as you can in regular C first. Okay, when you get down to the point where Well, I think we got it down to the point where everything is a single value relating to another single value, whether it's less than, greater than, or whatnot. Once you get to that point, then you can stop and go like, okay, I think I'm ready to translate all this code into assembly code at this point. So the advantage of doing it this way is you don't have to debug your program using the assembly the toy processor, which is I know it is a little awkward and is a little bit cumbersome, and that's why we don't want to do debugging until we absolutely need to do debugging in that particular way. Okay. The rest of this module is really a long example of stuff, and also just recommendations of how to label your how to name your labels when you're dealing with nested structures. And I found that most people they don't follow these because to follow this you have to kind of think in a much more mechanical way, and a lot of people do not want to think in a mechanical way. That's partially why we have assemblers and compilers, right? Is so that we do not have to think in a mechanical way. But so section 6 is just something that I want to kind of put out there, just so that you guys have an idea of how what is a structured way to name your labels. So moving on. Now, section 7 is really just a super long example. I am not going to explain this in words, okay, not spoken words, because it's already typed. There's no reason for me to type this up, and explain it in words. Okay, so what you need to do is to really look at this and work on it.